Hi, this is Christopher Boucher, and I'm going to review how to make a calculation of a z-score. And the times that we would use this is when we want to figure out, number one, it's a point. You have to have the point within a distribution to make this calculation, whereas coefficient of variation, you don't. It's more of a generalized type of calculation. The other thing is when we use a z-score, we can compare say a point in that distribution to another point in a different distribution when the means of each distribution and the standard deviations are different. So what we can do is we can figure out who earned a relative better score or worse score in some type of performance test or something like such as that, which is very similar to what we're doing here. Okay. A company accepts two types of IQ test results. Two different exams have different means and standard deviations. So you can see this would be a problem. We have two different types of tests, and one has a mean that's a much higher mean than the other one, and one has a standard deviation that's much different than the other one. So how would you figure out who did better? Well, you have to compare it within into a standardized form. You have to put it into the z-score form and then compare what that index value is, whether it's higher or lower. So it says use the data listed to decide who earned a higher standardized score. So that's what we're going to do. We're going to standardize these results based on this point estimate and apply it to what the norms are for the distribution, for each distribution. Okay, this is the way this looks. Make sure I'm on the page. It's a quick and simple calculation. We have that point that we're doing our test for, and then we have mu, and mu is the norm for, it's the mean for the distribution, and then we have the standard deviation for the distribution. So that's all the calculation is, and later we'll use this a lot. And you'll see on some of my other videos we use this a lot. And this is the foundation of the z-score, or using z-scores. Okay, so let's figure out what Joe's is, and then we'll calculate Sue's, and we'll see who did better. So Joe's is, let's see, 2, 1, 4, 4. Subtract the mean for that distribution, 1, 5, 0, 0. And then the standard deviation for that distribution is 200. Okay. Well, let's write out Sue's next before we do the calculation. So this is Joe. Now let's write down Sue's. So Sue's is 140. Subtract. So that's that right there. 80. And then over a standard deviation of 30. Okay, and this is Sue. Okay, so the answer for Joe's is, I already have this written out, 3.22, and for Sue's is 2. So who earned the higher so who earned the higher score based on the mean and the standard deviation for that distribution? Joe did. And it's because he's 3.22 standard deviations above the mean for that distribution. Sue did well, but she was 2 standard deviations above. So that is how we would compare different means and standard somebody's score within a type of distribution when it's hard to compare because the means and the standard deviations are different. Okay, thank you.